Hello, mathematicians, and welcome to this video for task 2.6. Today we're going to find prime factorization of different numbers. What do we mean by prime? Well, we mean numbers like 1, 2, 3, 5, 7, do not say 9, 11, numbers that can only be divisible by themselves and 1. So, what are the different factors that are only prime of a number? Well, let's take 36 as an example. We're going to do two methods. We're going to do the cake method and the tree method. So let's zoom in and do the cake method. So first, we draw a little box, little L, and think of it like completing the square, like we're drawing a box around it. So we're going to start with 3 times 12. That's 36. So then 12 can be broken down further into 3 times 4. 3 is a prime number. 4 can be broken down into 2 times 2. So you'll notice 3 times 12 equals 36. And then we've got 3 times 4 equals 12. And then 2 times 2 equals 4. So we've broken down any number that isn't a prime number into the primes. So how do we write this out? We write it in order. So we've got 2 times 2 times 3 times 3 times 3. I'm going to use the dot, not the x. So please get used to multiplying. Write a dot, draw a circle, but do not use that x. The other way we can write this is as an exponent. There are 2 2's. Ooh, that's a terrible 3. There are 2 2's and there are 2 3's. Now, do not worry about the exponents because we're going to get there. So this is the cake method. I don't like this method quite as much as the tree method, which is over here. So let's look at the tree method. So we start kind of similar. We're still going to break this down into products of primes. So 2 times 18. 2 is a prime number, so I'm going to circle it. 18 can then be broken into 6 times 3. 3 is a prime number. We're going to circle it. And 6 is 2 times 3. We're going to circle those prime numbers. So then we have 2 times 2 times 3 times 3 as our answer. Now you'll notice, wrong way. We got the same answer no matter which one we used. It doesn't matter which method, whatever makes sense to your brain. So now I want you to pause the video, try to simplify 30 divided by 36, enter your answer in formative, and then unpause the video to check your answer. All right, I bet you simplified the fraction using something like this. Now, this is perfectly acceptable. However, there is an easier way, folks. So instead of doing multiple steps, we can use prime factorization. So you'll notice that I want you to fill in 36 over 30. I want you to fill in those prime factors. So pause the video and fill in those factors right now. So we have our prime factors for each. Now we just fill them in on the line. So 30 is 2 times 3 times 5. And we know 36 is 2 times 2 times 3 times 3. So now the great thing is we can cross out any numbers that are the same on the top and bottom because we know 2 divided by 2 equals 1. So if you see a 2, cross it out, top and bottom, and a 3, cross it out, top and bottom. We're going to rewrite this as 5 over 2 times 3, or to simplify it further, 5 over 6. So the same answer that we got, just an easier way to do it. All right, folks? So now, if you look here at how are factors and prime factorization connected, I'm not going to go in depth on this, but I want you to notice that anything that's not a prime number, so 4 and 12, for example, we can break that down into its prime numbers to get our prime factorization of 2 times 2 times 3 times 3. So I want you to play around with this a little bit and figure out how prime factorization and factors are connected. Now, the last thing for you to do is fill out your vocabulary down here. You have to come up with your own example. Good luck, folks, and happy solving.